Okay, I'm going to continue 10.7 notes when we're talking about line segments created by the intersection of either secant lines or tangent lines or both. And for most of you guys, I just discussed theorem 10.16 with you guys, but for this we actually have an intersection on the outside at point A here. And what I want to do, the relationship here, is to take the segment that's on the outside, which is AB, and multiply that by the whole segment, which is AC. So I have an outside segment, and I'll call that outside 1, times the whole segment of 1 equals the outside of the second segment times the whole of the second segment. So for our relationship, the outside of the first segment would be AB, and the whole of the first segment would be segment AC. And then for the second part, the outside is AD, and the whole segment is AE. So we're going to use that same relationship for example 3. The outside of our segment is JH, and the whole segment then is JG. And that's going to be equal to the outside of the second segment, which is JK, times the whole segment, which is JL. And then we want to fill in our values. JH is 8. JG is the sum of the parts, so that's x plus 8. JK is 6. And JL is 16. And so now you have your equation set up correctly. We want to distribute on the left side. 8x plus 64 is equal to 6 times 16, which is 96. We want to subtract 64, which gives me 8x equals 32, divide by 8, and x equals 4. On the next page, it looks different because we have a tangent and a segment and a secant instead of 2 secants, but the process is the same. We still, from one segment, are going to take the outside of one segment times the whole segment. In this case, when we have a tangent, though, the outside and the whole segment happen to be the same. So outside 1 times whole 1, which means from the first segment, and then the outside of the second segment times the whole of the second segment. So the first one, I'm looking at JK. The outside is JK, and the whole thing is also JK. And that's okay if they're the same value. The second segment, the outside is JL. Let's try that again. JL, and the whole thing is JM. So let's apply that to example 4. We have a red segment and our blue segment here. And so for the red segment, we're going to have the outside, which is QP, times the whole segment, which is also QP. And that's going to equal to the blue segment, which is the outside is QR, and the whole segment is QS. And then I want to fill that in. QP is 8, so I actually end up doing 8 times 8. QR is x, and QS is x plus 7. So here's our equation. I want to simplify both sides. 64 is equal to, and I'm going to distribute the x, that gives me x squared plus 7x. I have 3 different kinds of terms. So I'm actually going to take everything to one side because I have a trinomial. So I'm going to take my 64 to the other side of the equation, and that's going to give me 0 equals x squared plus 7x minus 64. So I have a trinomial to solve here. We really have a couple of options. One of them would be to factor, and I can already tell you from looking at this that this is not factorable. That doesn't mean it doesn't have a solution. So our other alternative is to use the quadratic formula, and hopefully you remember that from Algebra 1. And the quadratic formula takes a quadratic in the form of ax squared plus bx plus c equals 0. And to solve for x, we take the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So that's our quadratic formula, and that'll help us solve for x. In this equation, x squared has a coefficient of 1 on it, and so that's actually our a. So a is 1. The b in our equation is 7, and the c is negative 64. That's what I'm going to use to solve the quadratic equation. So x is negative b, negative 7, plus or minus the square root of b squared, so 7 squared, minus 4 times a, which is 1, times c, which is negative 64, all over 2a. And as I simplify, I get negative 7 plus or minus the square root of 49 plus 256 over 2 times 1. Oh, actually, I want to fill that in up here. So dividing by 2. So when I'm going to use my calculator, I'm going to take the square root of 49 plus 256, and I get about 17.464 over 2. That plus or minus tells me that there are 2 options. One is going to be where I add, which is negative 7 plus 17.464 over 2. And the other one is going to be where I subtract 17.464 and divide by 2. I can already tell you by looking at the second option that when I change the sign and add, that's going to give me a negative, and that's going to give me a negative length for my segment. You cannot have a negative length. So I'm not even going to follow through with that. I am, however, going to do this one, and when I take negative 7 plus 17.464 and divide it by 2, I get approximately 5.2. So that is actually what x is approximately. X is approximately 5.2. Okay, you do have an assignment. It's page 753, numbers 2 through 14, the evens, and I will see you tomorrow.